In this video I will be demonstrating one of the applications that I created in Git recently. So this is a HTML file where using TensorFlow I am training models in the UI itself, and then the trained models I am sending back to the server where it can be stored, and later on by the model name I can retrieve it in this second table. So currently I have 3 models here, and then I can put some comma separated test data and I can test them against the model that I have selected. So initially let me show you how to train a model. So at this moment I have 3 models, square and square 3000. This is a naming convention I am using. So this one was a model trained for square values where input was being squared in the output, and there were 300 data set in the CSV, of which it was split 90-10. So 90% were in the training set and 10% were in the test set. Similarly, this is theta sine 3000 50-50. In this case I was training theta versus sine theta, where 3000 data were there in the CSV. 50% was used for training and 50% was used for testing. And this last one is theta sine theta 3000 90-10. So again this one is 90% test data and 90% training data, 10% test data. And for these last two I will be showing. So let me show you some older screenshots that I have while these two are trained. So this is the first screenshot, and this is for theta sine theta 3000 50-50. So 50% training set and 50% test set. So in this case you can see this was our input graph plotted, and this is our trained test data's output versus what was predicted by our model. So in this case you can see our model performed a little bit better in this lower range till 0 to something around 2.5, sorry 3 point something it looks like, and for higher values it had very huge errors. And this was for where it was 50-50. Let me show you the 90-10 one. So yeah, this is the 90-10 one. Here I saved the file name with this one, 90-10, and here you can see the final graph was a bit better. So it was predicting better than the 50-50 model. So in this case, okay, so before showing the prediction, let me show you how to train a model in this tool. So here I will choose a file. I can upload any CSV. So in this Git repo itself I have put some test data CSVs. Data 100, this contains 100 data sets, this contains 1000, 3000, 10,000. So for this video let me choose that 100 one because it will be easier to train for this video. So I can click on upload. Then initially the first column and the last column will be selected. First column will be treated as input, last column as output. We can change this one. This is num versus sine theta. So theta is calculated 2 pi some frequency multiplied by this num, and then sine theta is again sine of that value. So I can change it. Let's say I want to plot theta versus sine theta. So this will look like this one. I have some very less data set here in the 100 one, so it's not looking like sine curve. I will show you by changing it to some higher number of data, like the one having 300,000. That will look like a sine curve. So then again we have square. So for example I can take a num and a square of the numbers. So this is a square graph, and this way we can train any of the input and output pair. The only limitation this application is having is it can only take one input column and one output column. So maybe in future I will extend it, but as of now I don't have any plan. So let me show how I train these theta versus sine theta ones. So theta versus sine theta, let me choose this one instead of data 100. Let me choose 1000 one. So I have uploaded this one. This looks like sine theta, and this one I will train theta versus sine theta, and this says training data percentage. So initially it is 19%. For this video I will make it 50. So 50% test data and 50% training data. And this one, let me make it a little bit bigger. So So here you can see, if I enter a model name, this button says train model and save. If I don't enter a name here, you can just train the model, see the output here, and that's it. If you want to send the model to the server so that you can utilize that same model again in future by using it, and then using that same model and predicting against that one. So I am demonstrating the save value. So at this point I will give some name. So I will call it theta sine, and the data set is having 1000 data, which I have split 50-50, and let me train this model and save. So at this point you can see this in selected models we don't have this file name, otherwise it will override. So this is training is in progress. It shows with this dotted dots. So it will take some time. Let me pause the video for some time because it is 1000. It will still take some time. I'm pausing it. I will resume. Okay, so now our model is trained, and it took 61 seconds. And as you can see, this is even worse than the previous graph that I showed as a screenshot in the paint, like this one when it was 90-10 and this one when it was 50-50. And in both these cases it was trained on 3000 data sets. In this case we did it on a CSV that has only 1000 data sets. So once we had less number of data, as well as the training test split was 50-50. So in this case our model is performed very poor. There were some accurate values, still something around 1.2 or something, and post that it were a very huge error. So anyways, this model also got saved. So if I refresh this, and I can choose any model. So now see, this one is also showing sin theta 50-50. Before that, since we are testing against one model, so we need some test values to see. I'm uploading a file. Okay, so I have uploaded this 1001, and there are some values we can see. So for 2.66 theta, the value of sin theta is 0.45. So let us see which of our model is predicting this accurately. So I'm copying this value and putting it here. First I will test it with sin theta, the 1001, this performed poorly. So if I test with this one, I'm getting a value of 0.34. It's not very close. The error is huge. If I change it to 3050-50, so 0.38, it's a bit closer to the actual value, but still has some error. And now if I test it with the 90-10 test, so see, now it has most accurate value. It has 0.44. It predicted 0.448, which is approx 0.45. In this case it will be 0.46 actually, but it is bit more closer as compared to these other two models. So let me know guys how you like this one, and you can find the source code in this one. I will make my the last commit now, and if in case I need to see some improvement, I will do those also. Also there is this histogram which I am not able to fit as same size as the visualization tab. It is getting squeezed, so I will try to work on that one. Other than that, I think we are good for now.